So what we're going to do today, we're going to solve some equations. Okay, I'm going to give you a little bit of information about where you can get further support if you need to look up some concept or any other kind of mathematical things. Then we're going to look at what types of equations are there, trying to learn how to identify them. Then I'm going to go into details of few types of equations, solving linear equations and quadratic equations. And if we have got some basic, if you're going to have some time, we're going to look at some basic exponential equations. And the last thing is what happens when we combine together linear and quadratic equations. How can we solve those types of equations? So, I am the school's mathematics learning support coordinator. That means I am providing one-to-one tutorials as well as these kind of workshops. So if you come across with some mathematical needs or some kind of problems in your general studies about mathematics, you can always come and book a tutorial with me. If you can't make it in person, then we can try to organize it over Skype, or I'm very open to you sending me an email saying that this is the problem I don't know how to do, this is how I tried it, the answer should be this, but I'm getting this. And I can email you back with some little bit of explanation saying this is where you've gone wrong, this is what you should have done. Or if you just absolutely at loss and don't know how you even start, I can try to sort of explain that to you in writing. So that's again something that you can try. I also have a Moodle site, and you should have access to it automatically. Every student in the school, accounting and finance, yes. So you should definitely be on that list. You should have access to that Moodle site. Now on that Moodle site there are recommended websites, which generally in mathematics and statistics as well. So if you ever come across with some statistical packages that you want to use, data or SPSS, there are some videos there that can help you how to use those packages, as well as some explanation to statistical concepts, as well as mathematics. And I think there are a few recommended books as well, and websites as I mentioned. So that's a good thing to keep in mind. And there is one website which is also recommended up on the Moodle. Well, this is the website I really like. It's a collection of mathematical notes, starting from basic numerical skills and goes all the way up to calculus, differential and integral calculus. Now, you're probably not going to have to deal with calculus in accounting, but anything else like solving equations and the rest of it, they are there as well, so you can have a look and go through it. And just some basic concepts if you've forgotten about percentages or how to work with formulae. There are good workshops there as well. Now there are a lot of different types of equations, very different types of equations. So we have got linear equations, quadratic, polynomial, exponential, logarithmic, and a lot more. These are the most common that come up in the school, business, economics and informatics. Trigonometric is basically sine, cosine, those sort of things. Now, what is the difference between these ones? So, a linear equation is when you have got something like, I don't know, 3x plus 4 equals 7. Or 5x minus 2 equals 7x plus 2. The importance here is that you only have got x as the variable. And x is just to the first power. It's not two squares, it's not root, nothing whatsoever. It's just on its own. So whenever I would like to draw this equation, represent it as a function, I would be able to draw a linear line And that's why we call it a linear equation. Now the quadratic is different in a sense that in the quadratic you will have your x to the power of 2. That would be the highest power of x. Now in here, the second power is called the quadratic term. Where x is to the single power, that's called the linear term. And the standalone number, that's called the constant term. And depending on if you are missing one of the terms, linear or the constant, or you have got all of the terms, you would try to solve them slightly differently. Now the generic form of a quadratic equation is this, where a, b and c are constant numbers, and what's important in here, they are all real numbers, can be any, positive, negative, fractions, decimals, can be anything, but what's important here is that a cannot be equal to 0. So that means the quadratic has to be present, because if a is 0, 0 times s squared would be 0, and I would end up having a linear equation again. And the generic form for a linear equation would be bx plus c equals 0, or any other combinations, and the rule goes the same. B and c can take any numbers, but in this case b cannot be equal to 0, because otherwise I would not have an equation. Okay, now we start to talk about polynomials as soon as we have got higher powers than 2. Sometimes we call them cubic, quartic, depending on what the highest power is, but usually they're higher than 2. The exponential equation is quite different. Do you mind if I rub the board off? So the exponential is when the variable, the x, the unknown, is in the power. So if I still have something like 2 to the x equals 16, now the variable is in the power, so that's why I know it's an exponential. Okay, now this one would be a quadratic, because the variable is raised to a power, but now is a number raised to a variable power. So that's the main difference between exponential and quadratic. And a logarithmic equation, is when in the equation I have a logarithm. I don't know how much exposure you had for logs, but basically we can have any base of logarithm. If I write log, that always refers to 10 base logarithm. And what's important here is that somewhere in the equation I have a log sign followed by a variable, and that would be a logarithmic equation. This one is a very simple one. I can have more complicated ones. That would be still a logarithmic equation, and any kind of combinations, as soon as you got a log sign in here, we classify it as a logarithmic equation. Okay, loads more, but in business and economics you usually don't come across with the trigonometrics and the other types of equations. So what I'd like us to do now is have a look at each and try to find what type of equation every one of them are. There's no penalty for wrong answer, and studying is in the trying. So the first one would be linear. Second one would be Quadratic, yes. Now the third one is a bit tricky, isn't it? Because I'm looking at it and I just don't know if what's going on in here, because x is in both numerator and denominator. So for me to be able to identify if it's linear or quadratic, I would have to start manipulating it and see if I can bring it into one or the other standard form. Now, as far as I'm concerned, I think it's end up being a linear at the end because things cancel out. So, but then again, you would need to start to go through the problem solving process, and sometime through you would be able to identify it. The last one is actually much easier, because where is the variable? In the exponent. So this will be an exponential. I think I've got a few more. So on this slide, the first one would be logarithmic, yes. Because we have a logarithm in the equation. That would be a trigonometric, because sine and cosine are trigonometric functions. Now this is something that you probably don't see much. Now that looks quite complicated. Loads of brackets are going on, loads of fractions. But if you look at x, if you look at the variable, what do you observe?
The variable is that's part of the x.
No.
It's taking the power of it, isn't it?
No. This is basically a half times x. If I wanted to make it exponential, what I would need to do would be that.
Right.
Okay, so that's a difference.
Yeah.
So when you look at it, x is not in the power, it's just multiplied by numbers, but those are fractions, but those are still constant numbers.
Yeah.
Okay? Now, what's going on though is there are a lot of numbers, funny numbers all around the place, but x is not raised to any power.
Okay, yeah.
This is always just x. So it's a complicated looking but simple linear equation. So sometimes they can hide quite badly.
That's what's happening there.
Yes, exactly. And the last one, again, x is not in the power, but is x raised to the second power. So it's a quadratic again. Okay? Now, why is it important for us to know which equation is what? Because the solution process is slightly different for every type. For example, if I wanted to solve a quadratic equation, I would need to remember the quadratic formula. But for a linear equation, I don't need that formula, because I can just solve it differently. And again, for logarithms, I need to understand and remember what logs are, and so is for the exponentials, what kind of rules the exponentials follow, and so on. But we're going to go into these ones a little bit more details. So, start with the easy ones. I knew I was missing something. Not very useful. So what we want to do now, solve these linear equations. So 4x plus 16 equals 10. The final goal is to get to x and find out how much one of those x's is.
Yeah.
So I need to remove everything that's in my way. First, what I'm going to do, I'm going to remove the 16.
Yeah.
And by removing, I mean taking away the 16. Or move it to the other side, depending on what you were taught.
Yeah.
Now, if I move it to the other side, then that will become negative on the side, because anything that crosses through the equation line becomes the opposite. So positive becomes negative, multiplication becomes division, and the rest of it. So I've got 4x being equal to minus 6. And that means that x will be equal to minus 6 over 4. And I can cancel that down a little bit, because I know that 6 and 4 both can be divided by 2. So x is actually minus 3 over 2. And that's always useful to do the cancelling down, because these numbers are a little bit more informative than the version of higher fractions sort of things. Okay, that was the first one. The second one. What's going on in here is that I've got fractions. I've got 2 and 9. What I need to do first, I need to bring them to the common denominator. Now the common denominator is the smallest number that both 2 and 9 divides into without remainder. And in this case, that would be 18. So that will be over 18 plus that would be over 18. The other side will not change. Now, how many times 2 goes into 18? 9 times. So when I'm changing this into 18s, the x gets multiplied by 9. And how many 9 goes into 18? 2. So the x of this one gets multiplied by 2. And now I cannot like and like together. So I've got 9x plus 11, 9x over 18 plus 2 over 18, 11 over 18. I'm giving the punchline away here. Now, there is a over 18 here, so I need to multiply up by the 18. So 11x will be 18 times 4, 18 times 44, I have no idea. I need a calculator for that.
792.
That's lovely. So that is 792. And I want x, so I need to divide down by that 11, and that's going to give me x being equal to, hello. That's all right.
72.
Pardon?
72.
X being equal to 72. Okay, so that one was a little bit more challenging, but not overly difficult. So last one. I'm going to start that here. X over x minus 4 equals 8 over x minus 4. Now, as soon as you've got a variable in the denominator, you need to remember that the denominator cannot be equal to 0 because we cannot divide them by 0. For this kind of equation, I always have to start with saying, okay, the denominator cannot be equal to 0, so x cannot be equal to 4. Because if I end up with that solution, that is an invalid solution, so that would mean that my equation doesn't have a solution. And once I've got that, then I'm going to have to look at this equation and think about how to solve it. Now, what I also observe is that the two denominators are exactly the same. And how do we remove a denominator? Multiplying up by it. So what I'm going to do now, I'm going to multiply the whole equation up by x minus 4. So this will be x times x minus 4, and that will be equal to 8 times x minus 4. And multiply the brackets out. X squared minus 4x equals 8x minus 4.
32.
432.
Oh,
32.
I can't multiply. Okay, and what's going on in now? I ended up with x squared minus 12x plus 32 being equal to 0. I've got a quadratic in here. So I would need to remember the quadratic formula and then solve that. But I put it into the linear equation, so how come that? Come back to here, and what I observe here, the denominators are equal. So the two sides of the equation can only be equal if the numerators are equal to. So this would be the standard solution process, and going back to solving it by the formula, which I'm going to show you in a minute. But I can do away with all that, just observing that two fractions are only equal. When the denominators are equal, the numerators have to be equal too. So I can just look at it and say, okay, well, x have to be equal to 8 then.
Okay.
And I show you how to solve quadratics in a couple of slides. Then your homework is to go home and see that this would be, again, give you x equals 8. Any questions? Right, let's look at what's on the next slide. Some more linears. So what's going on in this one? Is that I have got brackets in this equation, and I've got x's all over the place. So what I need to do first, I need to remove those brackets and try to bring x's together to find out actually how many x's I have and what should they be equal to. So 8x, breaking up the bracket when it's a negative in front, it just means everything inside the bracket changes sign. So it will be minus 5 plus 4x. Same rule applies here. Minus 4x minus 9. Both of them were positive, now both of them are negative. Now I want to collect x's onto the same side. There are positive x's here, so I'm going to collect all of them here so I end up with positives. So 8x plus 4x makes 12x. And bringing these 4x over to this side again, that's going to give me 16x altogether. So now I did that with all of the x's. I just need to deal with the numbers now. On this side, I have got 6 minus 9, which is negative 3. And I have to bring a negative 5 over from here. So that would be negative 3 plus 5, which would give me positive 2. Was it too much? Okay. So that's how you can do quite a few things in one go, giving that you can keep it all in mind. So 16x equals 2. Now I need to divide them by the 16. So x will be 2 over 16, which is nicely cancelled down to 1 over 8. So that's the solution for this one. Then other one. What I see here again is that I've got two fractions with different denominators. I need to again find the common denominator. And in this case again, the smallest number that both 5 and 3 divides with that remainder is 15. So I'm going to have to make the two fractions into 15s. So I'm going to start like that. So how many 5 goes into 15? 3. So the numerator I had to multiply by 3. And here I need to multiply by 5 because 5 3s makes 15. But I've got these as well. And I want to bring them to the common denominator as well. But 6 over 15 would be 6 times 15. And same here. I've got 15 at the bottom, so I need to multiply the 2x by the 15. It doesn't matter which way you write, because the multiplication is always commutative. So I can deal with that. The reason why I've done it, because in this case, when I'm multiplying up by 15, basically I can just remove the denominators. So 6 times 15 is 90. 6 times 2 is 60, 6 times 3 is 30, so that's 90, minus 2 times 15 is 30, and from this point on is exactly what we've done in here. So we just break up the brackets, bring all the x's together, and then find how much one x is. So 90 minus 3 times 3 times 6x is 18x, and negative times negative is positive, and 3 times 4 is 12. The next bracket, 2 times 5 is 10, and 5 times minus 5x is minus 25x. So what I see is that there is only a negative x in here, while there are positive and negative x's here, so I'm going to bring the x over to this side. The 30x and the minus 25x gives me 5x. 18x plus 5x makes 23x. So therefore, I've got all the numbers now. Sorry, I've got all the x's now on one side. Now I just need to do the same for the numbers. 90 plus 12 gives me 102. Take away 10 will give me 92. So 92 is equals to 23x. So x will be 92 divided by 23. So x is equals
404. Yes, 4.04.
Oh,
92. Oh, sorry. 93, 92.
oh, okay. So that will be 4 then, right?
4.
Okay, well, that's fine, because I remember that the solution was a nice, easy number. And I was just, oh, have I screwed up somewhere in my solution process? No, good. Okay, so x is 4. And look at the last one. Now, again, what I've got here, I've got the variable in the denominator. So what I need to start with, making sure that neither of the denominator takes the value of 0, because then that's an invalid operation in mathematics, so my solution would not be complete, so I wouldn't have a solution. So x minus 4 cannot be equal to 0, that means x cannot be equal to 4. And if I look at this denominator, 2x minus 8 cannot be equal to 0, so 2x cannot be equal to 8, so x cannot be equal to 4. Now what's going on in here? They are seemingly two different denominators, but they're both giving me the same x that cannot be equal to. So that means actually, if I look at this one, I can rewrite that denominator as 2 times x minus 4. And why that is good for me? Because then the common denominator, which I need to multiply up by, is the 2 times x minus 4, meaning that this fraction will not change. I just need to multiply this fraction 2 at the top and 2 at the bottom. So 2 over 2 times x minus 4 have to be equal to x minus 2 over 2 times x minus 4. Now what I would do here then, next thing, is multiply up by the common denominator, or knowing that the denominator are equal, the numerators have to be equal too. Same result. And then what I need to do now, rearrange, remove the negative 2. So I've got 4 equals x. But I said 4 can't be x, because then I would end up with dividing by zeros. So what does it mean? This equation does not have a solution. And there are some equations that don't have solutions. You just probably don't see them very often. Now what it would mean is that if I was to draw the left-hand side and right-hand side of the equation as two different functions, they would not cross. Or if I was to rearrange it and draw it as one function, it would not go through the x-axis. Because when you have got a function, any kind of function, let's draw some funky function, something like this. This function would have two solutions. Solution 1 would be this, and solution 2 would be this. Because that is when you have got y equals 0. And that's when you would say, okay, maybe I could write something funny down. 3x cubed plus 4x minus 7 equals 0. So this is the function, and that is equal to 0. So that would be, hopefully, these two. But obviously, random function, random graph, nothing to do with each other. Okay? So that's what's going on in the background. That's where the kind of visual could help you to come in. So this function doesn't go through the x-axis. It's either above or below it. Now, when you solve quadratic equations, you have got two approaches that you can take. You either solve them by elimination, solve them by factorization, or you solve them using the formula. Now, the key steps for factorization is that you look at the constant term. So x squared minus 6x plus 8 equals 0. Ooh, that doesn't look like an 8 at all. So you look at the constant term, the 8, and you break it up into as many multiples of two numbers that you can just think of. So, how can I multiply two numbers together so they would end up being 8? Well, it can be 1 times 8. It can be 2 times 4. They both give me the 8. However, it can also be minus 1 times minus 8 or minus 2 times minus 4, because that would also give me positive 8. Now the key here is, what I need to find is what am I doing it the wrong way around? No, I'm not. Okay? Now, the next thing is that you want to see is which two to add together that would give you the negative 6. So 1 plus 8 would give me 7. That's wrong. 2 plus 4 would give me positive 6. So I'm almost there. And minus 2 minus 4 gives me the negative 6. So that is what I'm looking for. So this quadratic equation can be broken up as x minus 2 times x minus 4, and that has to be equal to 0. So that's the point of factorization of quadratics. Now it only works if the quadratic term has got a coefficient of 1. So the number, basically there is no numbers in front of x squared. If it was 2x, 4x, anything else, it probably doesn't work. It will not work, so that's why we got the formula as well. Let's get back to solving this. I have got a bracket times another bracket that has to be equal to 0. So a product is 0 if either one or the other is 0. So it's either x minus 2 equals 0 or x minus 4 equals 0. So x can be 2 and x can be 4. So what we actually found is that you've got a quadratic equation, positive quadratic equation, because the x squared has got positive, there's no negative in there. So that would look something like this. And this point is 2 and that point is 4. So that's what it means, solving them. That's what's going on in the background. Yeah? You took such a big breath, I thought you were going to ask something. Okay? Can I rub the board off? The next one, x squared minus 2x minus 3 equals 0. Now, I need to pick up the minus 3. I need to think about numbers I can multiply together, so they would give me negative 3. So, what are those numbers? Well, 3 is a prime number, so it can only be multiplied by 1 in itself. So it can be either minus 1 times 3 or 1 times minus 3. So out of the two, the solution will be, for the factorization, the one that when I'm adding them together will give me the negative 2. Well, minus 1 plus 3 gives me positive 2, so that's the wrong one. And 1 plus minus 3 gives me the negative 2, so this will be the right one. So this quadratic can be factored out as x plus 1 times x minus 3. And just for the same reason as before, either this term or that term have to be 0. So either x is negative 1 or x is positive 3. And the last one. Now, what you see here is that it's not in the standard form of a quadratic equation because it's not equal to 0. So before I can apply the factorization method, I need to bring it into the standard form of being equal to 0. So the -1 have to be removed to the other side. And why it's important is because depending on which side the constant term is, it will have got different signs in front. And that sign is very important for me to decide what will be the multiples. So the +1 is the constant term. So now I need to bring the +1 into multiples of numbers. Well, I don't really have too much choice, because it's either 1 times 1 or -1 times -1. Well, 1 plus 1 makes it +2, so that's wrong. -1 plus -1 makes it -2, so that has to be the same thing. So that means x minus 1 times x minus 1 have to be equal to 0. But that means x have to be equal to 1. There is only one solution in here. So what is actually going on with my function? What would it look like on a graph? So what it would look like, it's again a positive quadratic, but it would just touch the x-axis on one point, and that one point would be +1. Okay, there's just one solution, not two solutions. And obviously, if I have got a quadratic function that is up in here somewhere, maybe I should use a different color. If I had a quadratic function, that would be somewhere here, that doesn't cut through the x-axis, meaning that particular equation that comes with this function would not have a solution. And I could have another quadratic somewhere down here, that would be a negative quadratic, so I would have a minus sign in front of the x squared. Again, this would not have a solution because it doesn't go through the x-axis. Okay, so this is solving quadratics by using factorization, but as I mentioned, it only works if the quadratic term have got a coefficient of 1. Now, what happens if I have got quadratic equations that have different coefficients of 1? Now, for that, I need to remember the so-called quadratic formula. So if I have got the general form of the quadratic equation, knowing that a cannot be 0, the solution for any quadratic equation can be found applying this formula. Minus b plus minus square root of b squared minus 4ac over 2a, where b is the number in front of x, a is the number in front of x squared, and c is the standalone constant number. So for the first equation, this is nice and easy because it's in the standard format of quadratic equals 0. So I can just look at it and read off a equals 2, b equals -3, and c equals 8. And now, pick out those numbers and put them back into this formula. So I need the negative of b, -3 squared minus 4 times 2 times 8 over 2 times 2. And if you want to make your life easier, at this stage you pick up the calculator. Now, what you want to remember is that out of everything, this is a fraction at most. So for the scientific calculator, you need to press the fraction button. Then you type in minus bracket -3, or if you want to be lazy, you can put in +3 straight away, because negative of negative is positive. And then here comes, there's a plus and a minus here. Well, there's no such a sign in a calculator, so you have to go through the calculation with positive first and negative second. Simply because, generally speaking, quadratic equations usually have two solutions. So one of the solutions would be with the positive sign, and the other solution would be with the negative sign. So first I'm going to go with the positive one. So I'm going to put in the addition sign. Then I press the square root button. Then I open the bracket, put the -3 in, close the bracket, and then press the square button. Then I press -4 times 2 times 8. Now I have to come out from underneath the square root, so I need to press the right hand side button in the circle in the middle. Then I want to come down to the denominator, again by the navigation buttons, and then type in 2 times 2. Hit equal. Oh, and I've done something wrong. So I ended up with a error. Let's try again. -3 plus square root of -3 squared minus 4 times 2 times 8. So what's going on in here? What do you get in your calculator?
Function.
Yes. So what does it mean? Well, I need to look at this one. Okay, what's going on under the square root sign? -3 squared is +9. 4 times 2 times 8 is 64. So 9 minus 64. That is equal to square root of -55. Now, can I take a square root of a negative number? No, I can't. Because the square root is, what number do I have to multiply by itself twice to have -55? And to have a negative number, I have to multiply a positive and a negative together. Even if it's the same number, size-wise, one have to be positive, the other have to be negative. So what's going on in here? That this one has no solution. Well, strictly speaking, this one has got no real solution. Because the numbers can be extended to complex numbers, and then I would have a solution in the complex numbers, but it's no real solution. So basically, this is one of those equations that does not cut through the x-axis, it's further above. Okay, so this part of the formula, the b squared minus 4ac is called the discriminator, or capital D, and depending on if the discriminator is bigger than 0, I will have two solutions. If the discriminator is exactly 0, I have got one solution. And if the discriminator is negative, I have got no solutions. In most cases, we don't really bother about looking at the discriminator. But if you end up with having errors, then that is likely that the discriminator is negative. So you go back and check. Okay? Is that alright if I take the board off now? I might just keep that one there, just as a reminder. So, the next equation. Now, just by looking at it, it doesn't look like a quadratic equation because there is no x squared anywhere. However, I know that this is multiplication in here, and when I need to multiply x and 2x together, that's going to end up being x squared. So it is a quadratic equation, but kind of hiding in a way. Now, because it's a quadratic, to be able to solve it, I need to bring it to the standard form. So first I need to remove the brackets. So 2x squared plus 3x equals minus 12x minus 6. Now, the next step is arrange it to quadratic being equal to 0. So I need to remove the minus 12x. So 2x squared plus 15x. And I have to remove the minus 6, so that will be positive 6 equal to 0. Now at this stage, if you prefer the factorization, you could have a look and see, can I divide down the whole equation by 2 and still end up with whole coefficients? Unfortunately not, because 15 divided by 2 is 7.5. So as soon as you've got fractions in there, what do I need to multiply together to get 7.5? Million, well, infinitely many different possibilities. So the factorization would not work. I have to use the formula. So A is 2, B is 15, C is 6. So minus 15 plus minus square root of 15 squared minus 4 times 2 times 6 over 2 times 2. Now let's try that calculator again. Okay, so you press the fraction button first. That is this one. This one.
Oh, that one, okay. Yeah.
Okay, so you're pressing this button. And then now your cursor flashes at the top. So you type in minus 15 plus, now you press the square root button. So minus 15 plus, then the root button. Then under the root, you type in 15 and the x squared. Then you want minus 4 times 2 times 6. Now you have to press this button on the calculator. So you come out from underneath the square root. This one. The right hand side one. And then you have to press that button to come down into the denominator. So you're navigating around the screen with these arrows. And now you have to just type in 2 times 2. Then you can hit the equal button. And that's given me a rather nasty number. Okay, so that's given me minus 15 plus square root of 177 over 4. What the hell is that? Now, I want to make sense of this number. I have no idea how big this is. So there is another button, which is this one, SD. If you press that one, above the delete button, one of the red ones.
Okay, yeah.
Yeah. Now, that makes more sense. So actually minus 0.42 to 2 decimal places. Now, I want to find the other solution, because remember, we just used the plus. I want to find the other solution. Now, don't clear your calculator yet, because if you want to be savvy, what you're going to keep doing now, on the navigation button, press this. And press this until your cursor is flashing in between the plus and the root sign. Then you press the delete button. That got rid of the plus, and now you replace that with the minus. So keep pressing this, then once the cursor is in between the plus and the root, then you press the delete, and then you press, oops, the subtraction. And now you can hit equal, and then you ended up with that funny number again, but now instead of the positive, you have got the negative. I'm running out of space. So I have got minus 15 minus root 177 over 4, and again pressing the SD button. Now that's giving me minus 7.08 when I'm rounding it to 2 decimal places.
So I was a bit lost because I pressed shift and equal. It's giving me straight to that number.
Which number?
That's all right, because what happened is instead of I press the shift and equal, it's giving me straight that number. So
that's amazing. I didn't know about that trick.
When I've got fractions, I tend to always press shift
Equal.
And that's
Now you taught me something new.
Skips that bit of.
Okay, that's amazing. You know, I've been using this calculator for so many years, and there is always one more trick that you can learn about them.
Yeah, because I trying to do my homework, and so I was thinking, why do I have to do so? I tried shift and equal, and it gave me the right number. So now that's what I do, just in case.
Yes, that's brilliant. Yeah, as I said, I learned something new.
Yeah.
So yeah, that's my minus 7.08 to 2 decimal places when you're rounding it. Okay, so that was the second equation. Let's look at the third. So the third equation is 2 over x plus 1 minus 2 equals x over x minus 1. Again, what I need to start with, observing the denominators, because the variable is in the denominator. So neither of the denominators can be 0 because we are not allowed to divide by 0. So that tells me that from this denominator, x plus 1 cannot be 0, so x cannot be negative 1. And x minus 1 cannot be 0, so x cannot be positive 1 either. So I've got 2 restrictions on my x, what values my x can take as possible solutions. The next thing that I've noticed that it doesn't look like quadratic at all, because I can't spot the quadratic term straight away. So I need to start to think about solving it and see if this is actually going to end up quadratic or not. Now again, every time when you have got a denominator, to solve an equation with the denominator, I need to bring it to the common denominator. So what's the common denominator of x plus 1 and x minus 1? X plus 1 times x minus 1. Remember, when it was 5 times 3, when it was 5 and 3, the denominator was 5 times 3. So as soon as you've got 2 different denominators, a common denominator is always going to be the multiple of the 2. So what I need to do then That will be the common for both of them. Now, x plus 1 is already in here, so what I need to do is just multiply the top one, which is 2, by x minus 1. Now, I also have got that 2 in here. I want that to be the common denominator as well. So, I'm just going to have to put that common denominator at the top and at the bottom at the same time, because those two would cancel each other out, and I would end up with having just 2 there, which was the original one. Now here I have got the x minus 1, so the original numerator has to be multiplied by the x plus 1. And now I can multiply up with the common denominator, and I'm going to end up with 2 times x minus 1, minus 2 times x plus 1 times x minus 1 equals x times x plus 1. A lot of brackets. Too many. However, I just have to go and break them up each. 2 times x is 2x. 2 times negative 1 is negative 2. Now, what I see here is x plus 1 times x minus 1. And what I can remember is that if I have got the multiple of the sum and the difference of the same two numbers, that is actually the difference of the squares. So this can be replaced by x squared minus 1, because x is squared is x squared and 1 squared is 1. And I can break that bracket up as well. That is x squared minus x. X times x is x times x is x squared, and x times 1 is just x. Oops, that's positive, not negative. I still have got one bracket, so remove that final bracket. Minus 2 times x squared is minus 2x squared. Minus 2 times minus 1 is positive 2. Almost there now. I just need to bring it to the equals 0 form. Now, x squared has got a negative coefficient here. So if I want to have them positive, it's better to move everything from here to that side. If you don't mind the negative, just move everything to this side. I prefer to have the positive coefficients for x squared, because then I can see the function easier. So 0. Negative 2x squared goes to the other side, so altogether I'm going to end up with 3x squared, so this one's now gone. Then look at the x's. I've got 2x here, I have to remove that, so that would be negative 2x on the other side, and negative 2x and x makes negative x, and this is positive 2 here, so when it goes to the other side it would be negative 2. So that is now the standard form of the quadratic, and I can apply the formula. What I'm going to do, I'm going to need more space, so I'm going to have to keep those because I need to compare them. And now I'm just going to copy the original equation. Remember, I've got the freedom of swapping the sides of the equation around, because they just have to be equal to each other. It doesn't matter which side is 0. And then what I need to remember now, that A is 3, B is, what is B actually? Yeah, in here. Minus 1. Minus 1, okay? B would be 0 if there was no linear term. But because I have got one linear term, negative 1 linear term, that's why it's minus 1. And C is minus 2. So the sign always belongs to the coefficient. Again, pick up the formula. Negative negative 1 plus minus root negative 1 squared. minus 4 times 3 times negative 2 over 2 times 3. Again, pick up the calculator. Fraction negative negative 1 using the brackets plus square root bracket negative 1 bracket closed squared minus 4 times 3 times bracket negative 2 bracket closed. Come out from the square root, go down to the bottom, 2 times 3, and that is equal to well, I've got 1. And then I keep going back until the cursor is in between the root and the positive sign. Then press the delete and replace that with minus. And then the answer now will be minus 2/3. And for this one, I don't want the decimal equivalent, because the decimal equivalent would be minus 0.666 recurring. So this one is a more exact answer, because it's an infinitely recurring decimal fraction. At some point I would need to round. That would give me rounding error. However, if it was a question such as what's the price, you can't give minus 2/3 as the price. So it would have to be a decimal. But that would bring me a different problem, because can I have a negative price? So for those kind of practical solution, only the x equals 1 would be a valid solution. Because you're not giving away your product and then giving money to your people. Would be nice if life worked like that, but nothing comes for free, let alone with extra money for you when you're buying something. Okay. No. No, it's basically they just put on a ridiculously high profit margin and they're just willing to give a tiny little bit. They're making enough profit. None of these supermarkets went ever under, so they know what they're doing. They've been there for long enough. Okay, now exponential equations. Now, I'm only going to show you some very, very simple exponential equations. But whenever you have to work with exponentials, you have to remember the laws of exponents or indices, depending on what you call them. Because we call them exponents, indices, and powers. Those three words mean exactly the same. There is something in a power in the exponent. So anything, and by that I mean any whatever number, positive, negative, decimal, fractions raised to the 0 power are always equal to 1. Don't ask me why. It's a definition. Definition means you have to learn it. And if it wasn't like that, mathematics wouldn't work. So we need that for the consistency, the sake of mathematics. A to the 1, now that's a bit more logical, because the power basically means how many times I need to multiply the base together by itself to get to the answer. So something multiplied by itself once, it's itself. The negative power is just the 1 over the positive power equivalent. If I've got a 1 over n power, that's the same as the nth root. If I have got the m over n power, then that's the mth root of the nth power. See that the denominator is the one that always ends up being the root, and the numerator is always the power. Now, if you have got two numbers, same base, but different powers multiplied together, then you can just add the powers together. Again, you have got the same base, but now you're dividing your numbers, then you can just take away the powers. And if you raise a power to a power, that's the same as multiplying the powers together. Now, from about here, this one you can prove, and these ones can be proven quite easily. So these are laws. These ones are more or less equivalences, but these ones are definitely definitions. As long as you remember them, solving exponentials are easy peasy. Now, what happens if I have got different bases but raising them to the same power? Well, that's basically just multiplying the different bases at the same power. And the same for the division. Okay, if I put two different bases, dividing them but raising them to the same power, I can raise those powers individually and then divide. Okay, now I'm not expecting you to learn them just from looking at them once, but what I'm going to try to show you is how to use them to solve basic exponential equations. So first, now every time I see an exponential equation, what I first want to find out, can I write both sides of the equation using the same base and write it in a power form? So the question is basically, can I express 16 as a power of 4? Yes, I can, because 16 is 4 squared. But isn't that lucky? If the bases are the same, the two sides of the equation can be equal only if the powers are the same as well. So that means that x has to be equal to 2. That is one of the basic ways, basic methods of solving the exponential equations. Try to transform both sides to the same base power and then equate the powers. If that doesn't work, then you have got some other ways of doing it, which we're not going to discuss today. If you're interested in that, come and see me in a one-to-one. Second, 2 to the 5x minus 3 equals 32. Now, can I express 32 as a power of 2? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I doubled 5 times. That means this is 2 to the power of 5. Again, the bases are the same, so the equation can be true only if the powers are equal to. So that means 5x have to be equal to 8, so x have to be 8 over 5. And then look at the last one. Now, what's going on in here? Well, look at 125. If I divide that down by 5, I end up with 25. So 125 is actually 5 to the 3, or 5 cubed. Now that's almost good for me, but on the other side I've got 1 over 5, not 5. So can I express that 1 over 5 as a power of 5? Well, I can, because I remember that there are so-called negative powers. So 1 over 5 is actually 5 to the minus 1. So in the bracket, that is 5 to the minus 1. Well, I'm almost there, but that's minus 1 is in my way. But what's actually going on in here? I'm raising a power to a power. So that means I can multiply the powers together. So this is nothing else but 5 to the minus 1 times 3x minus 2. Now, minus 1 times 3x is minus 3x. And minus 1 times minus 2 is positive 2. And now I have got the same bases. So if the bases are the same, the powers have to be the same as well. Otherwise, the equation will not hold. So minus 3x plus 2 have to be equal to 3. So take away the 2. Minus 3x equals positive 1. Divide them by the minus 3, so x have to be equal to minus 1/3. Now again, that's an infinitely recurring decimal fraction, so I would leave it in this format. Strictly speaking, every time you found a solution for an equation, you need to substitute it back into the original equation and see if that's actually actual solution to the equation or not. In most cases, we don't have time for that. It's not necessarily expected of you to do the checking. But we can sort of, just for the sake of this, because it doesn't look very helpful, I can't really just look at it and say, oh yeah, like this one, it was obvious that this is the solution. But just for this one, let's try to go through it. So 1 over 5 to the 3 times minus 1/3 minus 2. I need to do a little bit of calculation here. 3 times negative 1/3 gives me negative 1. Negative 1, negative 2 gives me negative 3. One over 5 to the negative 3, you can either put that into the calculator or take my word for it, is the same as 5 to the positive 3, which is conveniently 125, which is the other side of the original equation. So yes, this is a solution. I mean, what I'm actually using here is that I have got two different bases. I'm raising them to the same power. So that is 1 to the negative 3 over 5 to the negative 3. A negative power is 1 over the same power. So that's 1 over 1 to the 3 divided by 1 over 5 to the 3. Well, 1 to the 3 is still 1. 1 divided by 1 is still 1. So this is 1 divided by 1 over 5 to the 3. How do I divide a number by a fraction? Multiply by the reciprocal. So this is the same as 1 times 5 cubed over 1. Well, that is just 5 cubed. So yes, it is 125. Mathematics works. in most cases at least. Okay, simultaneous linear equations. Now, they're called simultaneous linear equations because we have got two linear equations, two variables, which we have to solve simultaneously. So, there are two ways of solving these equations. One method is called the solution by elimination, and the other method is called solution by substitution. So first I'm going to show you the elimination method, and then we'll look at the substitution method. The key of the elimination method is that either the first variables or the second variables have to have the same coefficients. And the coefficient is always a number that's multiplied by that variable. But we are spoiled for choice in here, because x have got the coefficient of +1 in both of them, and y has got the coefficient of -1 in one and +1 in the other. Now, if the two coefficients are positively equal in both of the equations, I can subtract the two equations and eliminate one of the variables. If one variable is the positive equivalent of the other variable, like with the y's, -y and +y, then I can add the two equations together and eliminate the variable that way. The solution will give you exactly the same thing. Now, I prefer addition to subtraction. So what I'm going to do in here, I'm going to add the two equations together. So basically, x minus y equals 2, and x plus y equals 3. I'm just going to add them together. So x plus x makes 2x, minus y plus y makes 0. So this is actually the elimination part, because by adding the two equations together, I got rid of y. And 2 plus 3 makes 5. So x is equals 5/2, or 2.5, whichever you prefer, because this is now a finite decimal. Now I've got the solution of x, but I also have to get the solution for y. For that, I can go back either of the two equations, make no difference whatsoever, substitute the value of x back, the known value, and find the value of y. Now I'm going to choose the second one simply because y is positive there, so it will be easier for me to do the calculation. So 2.5 plus y have to be equal to 3. That means that y have to be equal to 0.5. Now, what have I actually found here? If I look at the two equations individually, separately, and I draw them as lines, they would cross somewhere, and that particular point would be 2.5 in the x-coordinate, and I probably went too far in here, 0.5 in the y-coordinate. So this is what it means by solving the equation. I can identify the coordinates, both the x and y, of the intersection of the two equations, drawn as functions. Okay? Now that's the elimination method. The substitution method is slightly different. In the substitution method, all I'm doing is I'm looking at one of the equations, manipulate it so I can express one of the variables as a function of the other, and then pick that up and substitute it back into the second equation. Now, in the first equation, I've got x minus 3y equals 4, and the second equation, 5x plus 3y equals minus 1. Expressing x would be very simple from here. So from this equation, I can say, okay, well, x is nothing else but 4 plus 3y. And now I can pick that up and put it back into the place of x in here. So now I've got a bracket I need to remove. 20 plus 15y plus 3y equals negative 1. 15y, 3y makes 18y. Take the 20 away. So that's minus 21. So it's positive 20 will be negative 20 here. Negative 20 minus 1, minus 21. So y is equals minus 21 over 18. Now I pick that one up. What is that?
Minus 1.1660.
Oh, okay. So I'm going to leave it this way. Now I pick up this y and put it back into here. So then what I've got, x equals 4 plus 3 times minus 21 over 18. So x is equals 4 plus, actually not plus, because positive times negative makes a negative. So it's 4 minus. Now what I see is that 3 and 18 can be cancelled down. So that will be 1 and that will be 6. Because 6 times 3 makes 18. So that is 4 minus 21 over 6. Now this is a fraction I need to take away.
So 21 is 3.5 minus 3.5. 4 minus 21 is 3.5.
21?
Yeah.
Okay.
Minus 3.5.
Okay, we can look at that. That's actually quite good. So 21 and 6, 3 goes into both of them. So 7 over 2, which is 3.5. Oops, 3.5, not 3 over 5. And that's easy, because then that's going to give us a 0.5 of being x. Okay, I was going to change this into 6, take away, and then cancel down, and probably would have ended up with, well, definitely would have ended up with 0.5 as well. Okay, again, I've got the solutions, x and y. So again, I found the coordinates of that intersection point. Now, can I solve this equation in a slightly different way? Can I use the elimination method here as well? For every simultaneous equations, you can use either of the method, doesn't matter. Probably the elimination method would have been easier here, because if I just add the two equations together, the y straight away disappears, so I wouldn't have to go through that relatively complicated method of substitution. And the answers would have been the same, because I would have ended up at 6x being 3, so x being 3 over 6, which is 0.5. And then I could have come back to either of the equations and so for y.
If the y coefficient, the coefficient for y had been different,
Yeah.
you wouldn't have been able to eliminate.
I can still eliminate, but that would have to be a slightly different approach. I can always eliminate.
verify that you have the same terms?
Don't even have to do that, because you can manipulate the equation, so it would become the same. So if I had something like 2x minus 4y equals 12, and 5x plus 3y equals minus 1, just keep that one. What I see here is that neither of them is the same. But if I multiply this equation by 5 and this equation by 2, I can make both of the x's being positive 10. Or I can multiply this equation by positive 3 and this equation by positive 4, and then I would end up with minus 12y and positive 12y. And again, I would have the same coefficients, and then I could do the elimination. So I can always do the elimination. If that's your preferred method, just remember that I can manipulate either of the equations as long as I multiply every single term by that same number. Not just the x, not just the y, everything in the equation. And that will work the same way. Depends on what takes your fancy. And that's the beauty and the curse of mathematics. You can do the same equation in about 5 different ways. Do you mind signing it for me? I forgot to ask. Because unfortunately that doesn't register on my register. Oh. Which is a bit annoying. Okay. Now again, if you work in economics or business or something, you probably come across these equations as prices and quantities in supply and demand analysis, for example. So I've got Q being equal to minus 45 plus 8p, and Q being equal to 125 minus 2p. That's the first equation. Now what's going on in here? When I look at these equations, what I can see is that on the left-hand side of both of them, there is just a single Q. So the left-hand sides are equal. But that also means that the right-hand side have to be equal as well, otherwise the equations would not be holding true. So in this case, I can just say, okay, minus 45 plus 8p has to be equal to 125 minus 2p. And now I've got one equation with one variable. So I can just solve it. 8p is positive here, the 2p is negative in here, so bring them both to the positive side to make it 10p, and remove the minus 45 to the other side again to become positive. So 45 plus 125 gives us 170?
Yes.
So if 10p is 170, then p has to be 17. So I'm just dividing them by 10. I've got p now, so I just need to come back to one of the original ones. Makes no difference which one. I'm going to pick the bottom one. And just substitute the value of 17 back into the place of p. 2 times 17 is 34. And 125 minus 34 will give me the Q being, pardon? 91. And that is the equilibrium price and quantity. Basically, when the supplier is happy to sell and the buyer is happy to buy. The second equation, or rather the second system of equations, is slightly different, because now I don't have the Q equals on each side. The Q's and the P's jumbled up in the equation. But what do I notice? This is negative q, this is positive q. So if I add the two equations together, I can eliminate the q. So 13p plus 4p makes 17p. Minus q plus q makes 0. And don't forget that there is a minus 24 on this side as well. And that is equal 27 plus 0, which is 27. So the 17p have to be equal to 27 plus 24, 51. So p is 51 over 17. Is that any?
3.
Oh, nice. So p is 3. And now I've got the choice of coming back to either of these. I don't know, go for the bottom again. So then q plus 4 times 3 minus 24 equals 0. 4 times 3 is 12. Minus 24 gives me negative 12. So q has to be equal to 12. And again, at the price of 3, I can sell 12 goods. And everybody's happy because I can get my profit and this buyer is happy to buy. Doesn't think that I'm too expensive. Obviously would prefer smaller price, but that would eat up into my costs. Any question? Now, what happens if I have got quadratics in my equations? In most cases, elimination will not work in the quadratic. As soon as I have got linear terms or multiples of x and y's, I probably can't eliminate at all. However, just to contradict myself, the first example I'm giving you is not one of those. Because in this special case, what I can see is that there are only x squares in both of the equations, and there are no linear terms to mess me up. So, what am I doing? So what I can actually do in here, I can subtract the two equations. And if I do so, x squared minus x squared, 0. So I got rid of the x squared. Y squared minus y have to be equal to 1 minus 1, which is 0. Now, this is a quadratic equation which misses the constant term. To solve these kind of equations, I need to make this into a multiple or factor it out. And then obviously, the two terms, either one or the other, have to be 0 for the multiple of them to be 0. So the two solutions for y would be 0 or 1. And then what I need to do is pick up each of them and then go back to either of the other equations. So y plus x squared equals 1. So if y is 0, then this equation will be x squared equals 1. So x can be positive or negative 1. And if x is 1, sorry, if y is 1, then 1 plus x squared equals 1. X squared equals 0, so x is 0. Now the solutions I've got now is 1, 0, minus 1, 0, and 0, 1. Remember, x is always the first and y is always the second coordinate every time you talk about pairs, ordered pairs. So, what's actually going on in here? I've got these two equations. This is obviously a quadratic. That is probably another quadratic, and then basically the two equations would cut through each other 3 times. Okay, I would need to manipulate them a little bit to actually see what's going on, so I'm not going to attempt to draw them. But it means that the two lines that once you draw them in the coordinate system cut through each other 3 times. Okay, that was the one of them. Again, I could only use it because there were no linear terms of x. If I had a plus x here now, that wouldn't have worked. Because if I subtract the two of them, that positive x would have stayed. So I would have ended up with one equation, but both of the variables in. So the second one, now the trouble here is that in the second equation I've got x times y. There is no way I can add or subtract the two equations together, which would mean that I could get rid of either x or y. So I've got no choice, I have to go down the substitution method. So I can express either x or y from the first equation. Well, let's do x, makes no difference. And then substitute that back into the second equation. So I need to break up the bracket. 5y minus y squared equals 6. Arrange it into the 0 format. So y squared minus 5y plus 6. And now this is a quadratic, and I have to solve it. Which way do you want to solve this quadratic? Formula or factorization?
Factorization.
Let's do the factorization then. So, what are the numbers that multiplied together give me 6? Well, 1 times 6 minus 1 times minus 6, 2 times 3 minus 2 minus 3. Now, 1 plus 6 is 7. That's not going to work. 2 plus 3 is positive 5. I'm almost there. I'm going to need the negative version. So, 0 equals x minus 2 times x minus 3. That means x, I'm solving for y. Well, it doesn't matter if it's x or y. In this case, so y is equal to 2 and y is equal to 3. Oh, that doesn't look like a 3 at all. Okay. So now, if y is 2, I'm going to have to come back into here and solve for x. So x equals 5 minus 2, so x is 3. And if I have got this one here, 2, 2, 2, so y can be 3 as well. So then x would be 5 minus 3, so x would be 2. So the two solutions I have is 3, 2 and 2, 3. So these only cut through each other in 2 points. Okay? And the last one. We have got just about enough time to do it. Again, unfortunately, I cannot just add or subtract the two equations together because I would still have the linear terms. So again, have to go with the substitution method. Easier to pick up the first equation and then say, well, x is equal to 14 minus 2y. And I can just substitute it back into the second. But now I've got a problem because I've got a difference of two terms that I have to square. And that is nothing else as the square of the first term minus the double of the two terms multiplied together plus the square of the second term. So I've got 14 squared minus 2 times 14 times 2y plus 2y squared plus 4y squared equals 100. 14 squared is, I can't remember. 196. I would have said 169, so that would not have been useful. 14 times 2 times 2, that's basically double 14 times, double 14 twice. So that's 28, and double of 28 would be 56. And 2y squared is 4y squared. The other two, I'm just keeping them. Now, I have got 4y squared giving me 8y squared minus 56y, and I've got 100 over there, so I need to take that away from here. So that's just going to give me positive 96. But then when I look at these numbers, I can definitely cancel them by 2, every single of them. I probably can get away with 4 as well, or maybe even 8. So you've got the calculators. So if I divide the whole equation by 8, then I end up with y squared minus how many?
7y.
And again, because y has got the y squared's got a coefficient of 1, I can again think about the factorization. So what are the numbers I can multiply together to get 12? Well, the minus 7 here would be minus 3 and minus 4. And that is a multiple of 12. So that factorization is y minus 3 times y minus 4 equals 0. So y can be positive 3 or positive 4. Now I've got the y, so I need to come back to the original here to find x. So x will be 14 minus 2 times 3 or x will be 14 minus 2 times 4. So x is equals 14 minus 6, which is 8, or x is equal, no, sorry, 14 minus 8, yeah, that is 6, right. Okay, so the two solutions is 8, 3, or 6, 4. And I think that was the last question on the slides. Lovely. Have you got any questions for me? Now, I probably have shown you a lot more than what you will need in business and economics and accounting.
Now I came more for
The calculator.
Exactly.
Now.
I tried to book a class for that, or a workshop for the calculator.
Yeah.
But nothing came up. I don't know why. So because at the same time I'd also booked this one, I thought if I came to this one, probably know more of this.
Okay.
But I
now.
found out many things since then. So.
The annoying thing about the calculator is that I did have a calculator workshop, which was fully booked,
Yeah.
So that's
and then nobody turned. Fully booked, and then what? Say about 7 people turned up out of the 20 or 30.
Yeah, but I booked it, but I never get a confirmation of it. I didn't get a confirmation.
That's probably because by the time you booked it,
I thought
it was probably.
No, but when I booked it, said it had seven spaces left. But I didn't get the usual email, because when you book, you get a confirmation email, and then you get a reminder, but nothing happened. So I booked this one. I think I got another one coming up. I don't know. I can't remember what it is for. I booked them all the same day, so I only got 2 confirmations, and
That is more than annoying.
yeah,
That is
and
more than annoying.
And I actually, at that time, I was actually desperate to come because I needed to. I couldn't. For some reason, I could not work my calculator the way I wanted it.
Okay, right. Now, I did make some videos on how to use the calculator.
Okay.
So if you go to Google and type in BBK, oops, not BBRK, BBK lib guides, which is basically the library guides. You go there and you go for management and business.
Okay.
And the last tab here is scientific calculator tutorials. And then you can find, I think, 5 videos on scientific calculator. The last 2, this one is the settings and modes. So how can you sort of play around with your calculator? And this one is how you can use your calculator for basic statistics. And there is a module in accounting, which I can't remember now which one, but when you have to calculate portfolios and correlations and the rest of it,
That's what I'm doing now, yeah.
there is an example in the statistics one, which shows you how you can use the scientific calculator to check if you've done the correlation calculation correctly. Because if you put the data in the right way, all you have to do is press a few buttons and you get the correlation coefficient straight away. Okay? Unfortunately, that's not enough in the exam because you have to demonstrate that you know how to do it. But the calculator is there to double check if you've done it right or not. Okay?
Thank you.
Any other questions? I mean, that one is very useful, the 4, setting the modes, because sometimes you end up with linear mode instead of the natural mode, and then you end up with E cap kind of things instead of E and the power nicely being in the power. So look through that video and then you will be able to get through.
Excellent. Thank you ever so much for your time.
You're very welcome.
Yeah. I don't know why people are signing up and not showing up. Yeah, because it's the last tutorial that I came in with you. it was fully booked.
Yeah.
I checked like you see that it's fully booked, and then they don't do a good job of like sending reminders if you're on the waiting list.
Yeah.
And I just happened to look again, and I was able to slip in. So, so it was still fully booked.
Because when I tried to book, it said it had 7 spaces.
Mm-hmm.
The only thing is, straight away, I got a confirmation of the other 2. This one and the next one, which is sometime in December, I think, or January. However, I thought one I wanted most, which was the calculation, because this, I've done this before, because I've done another degree somewhere, and I know this, but I wanted to come because of calculations.
Yeah, because you've forgotten now how to use the calculator, because that's again quite...
Yeah, because of this, and I need this, the one I need to work with. So there are functions which I wasn't quite sure how to, but playing about, you find out.
Yes.
But, just if there's a workshop, why not go to one?
Exactly.
Yeah.
So watch the videos. If you still have got some questions, I'm around up until Christmas, so more than welcome to book a tutorial, and then we can look at more of the functions of the calculator as well.